My name is Rihanna Putnam, and I'm the Community Engagement Specialist for the Citizen Science Association. I have just a few slides about the CSA and some housekeeping notes, and then we'll turn it over to Caroline, Bucky, and Jill to talk about citizen science project selection for your courses. The CSA is a member-driven organization that connects people from a wide range of experiences around a shared purpose of advancing knowledge through research and monitoring done by, for, and with members of the public. Our efforts are concentrated into a biennial conference. Our next one is in Arizona in May of 2021. We have a peer-reviewed journal and member services such as our working groups, online networking, and webinars like these. Our membership represents the multidisciplinary and multidimensional nature of the field and includes project leaders, researchers, educators, and more. Now is a great time to join, and you can find more information about that on our website. We have 9 working groups that explore cross-cutting issues like ethics, environmental justice practitioners, policy, education, and more. Our working groups are one of the key ways that we advance the goals of CSA through sharing of resources, best practices, and relevant information, both among group members and also to the broader citizen science community. We're looking to revive our education working group and hope that many of you will find connection and inspiration there. We have several more events coming up, including 2 more of these virtual happy hours, one on assessing student participation in citizen science on Friday, June 5th, that's in 2 weeks, and then another one, I have the wrong date on that, that's actually June 12th, on using citizen science in non-STEM courses, and so those will be back-to-back in early June. We also have a webinar on the 28th, which is next Thursday, on citizen science, community engagement, and the UN Sustainable Development Goals. That should have some interesting perspectives on using citizen science to help measure progress towards the UN Sustainable Development Goals. And we're also excited to be hosting a town hall on Tuesday, June 3rd on volunteer fieldwork and during COVID-19. And so just getting some perspectives and talking through some issues that folks might be facing when trying to reintegrate volunteers into fieldwork after this extended time at home. So hope you can join us on some of those. Though this webinar was free to join, it isn't always free to produce, and we do appreciate your support however that may come. One of the ways that you can help support these free community-led webinars is by becoming a member. You can learn more about membership on our website, and we also have a donation page, and you can either text to donate or I'll share a link in a follow-up email. And donations of any amount really help our webinar series. Lastly, we do have this event set up in meeting mode today and look forward to hearing from many of you later. But for now, if you haven't already, please double check that your audio and video are both off just to make it a smoother presentation in the beginning. And if you want to, if you haven't already, you can go ahead and introduce yourself in the chat and we'll direct questions. You can place them in the chat, or actually it's a lot easier if you want to put them in a Google Doc, which I believe Caroline has shared and we'll share again. But that way we can better track questions and answer them and share them with everybody who wasn't on the line today. And so we'll hear more about that in just a minute. For now, I'm going to turn it over to Caroline Nickerson, who's a program manager at SciStarter. And we also have Bucky Gates, who's with the bioscience department at North Carolina State, and Jill Nugent, who is with Southern New Hampshire University and also affiliated with SciStarter to lead today's discussion. Thank you all for being on today, and big thanks to our presenters for sharing.
Yeah, thank you. And I know we have a few poll questions for you all as we do our kind of introductions, just for fun. So feel free to answer those if you would like. I think Rihanna has them queued up and ready to go.
Yeah, so we have a quick poll. Just tell us a little bit about yourself here. I'll give you all just a minute or so to answer those.
Even if you've never used citizen science in your classes, it's okay. That's why you're here. Don't be shy about answering honestly in our poll. Okay, it looks like almost everybody's voted. All right, we got a lot of folks in the life sciences here, and we got quite a few people saying, a majority saying they use citizen science in their class sometimes. A significant group has never used it, and some people use it often. So Awesome, good spread here. Thank you so much for being here. So you are here because you want to learn about how to select a citizen science project for use with undergraduates. And another reason you might be here is to discuss it with each other, because this is a happy hour, right? So we purposefully structured this. So the first part, we're going to talk a little bit about our experiences with this topic, frame some ideas for you all, and then the second half of this, we want you to use that Google Doc that I dropped in the chat to put some questions, comments, what you want to hear, and then we'll open up the floor. So we'll just go ahead and get started. So I'm Caroline Nickerson. I'm with the SciStarter team. On the line with me, I'll let them introduce themselves. Jill?
Hi, thanks, Caroline. Yeah, my name is Jill Nugent. I live in North Texas, north of Dallas. I serve as the Associate Dean of Science at Southern New Hampshire University for the online courses and programs, and serve on the SciStarter team and write citizen science columns for NSTA, and I'll pass it to Bucky.
Hi, everyone. I'm Bucky Gates. I work in the Biological Sciences Department at NC State. I'm a paleontologist by training, but I teach mostly non-majors bio courses. And so I do a tremendous amount with all the different fields of biology, but I'm also, by more specific training, a geologist. So I am very much interested to hear what all you physical sciences folks have to say and questions that you guys have.
Good stuff. All right, so I'll let Jill get us started.
Thanks, Caroline. Yeah, so citizen science with undergraduates. Citizen science is such an excellent fit for a multitude of our audiences across the higher education learning landscape. And so, like in the introductions we see from folks, whether you teach online, remote, distributed learners, face-to-face, or in blended learning environments, whether you teach science lab courses, courses serving science majors, courses serving the diverse non-science major audience, gen ed courses, pre-service educator courses, or if you're working with co-curricular projects such as campus events, student clubs, service learning, experiential learning, learner engagement with university museums and libraries. We could go on, right? Citizen science can be such a great fit for your undergraduate student audience. And I think it enriches the overall student learning experience. So we're delighted to discuss and share ideas with this amazing group today. Feel free to share any ideas throughout the webinar. We welcome and invite all of your ideas, resources, questions, tips, and suggestions. We can crowdsource ideas together in the spirit of citizen science. The higher education citizen science learning landscape is diverse. It's growing, it's ripe with opportunity, and such an exciting space to explore for faculty, staff, administrators, researchers, practitioners, everybody. So thank you all for being part of this conversation. Next slide. Yeah, so we thought we'd start with a brief conversation about where to find projects. So many of you guys are associated with universities, libraries, and museums where you have citizen science projects based at your institution. And we'll actually hear about some of those later in the discussion. So you may have that perfect project that's based within your home institution in mind. For example, the University of Oklahoma, they're my neighbors to the north. They have a number of OU-based citizen science projects associated with research lab groups, such as the What's in Your Backyard project. That's just one example. As well as lab groups associated with the Sam Noble Museum. The herpetology group has as an amphibian citizen science project. And so that's fantastic if you have projects in mind from your institution, or perhaps projects where you serve as the director, or citizen science projects that you have in mind to develop in the near future and open up to students. So that's fantastic. For folks exploring available projects, the SciStarter.org site and its powerful project finder can really serve as a one-stop shop to explore the citizen science ecosystem of resources, where you can locate the perfect project for your higher ed audience, whether it's for your 3-credit course, a 1-credit lab, a condensed semester, service project, event, other campus activity. The Finder tool will help you search for and discover the right project or event for your needs. And so it's really an excellent, helpful, one-stop shop place to start. Everybody is so busy, and so this is an effective, efficient way to search for and locate citizen science projects for your audience. So I'm going to pop some links in. Next slide. Yeah, so on the intro page, there's a project finder, but there's also the advanced search project finder on the .org/finder link. The advanced search, you can search for projects for college students for your age group that include curriculum materials, projects that are online. We had a lot of folks, of course, with what went on in the spring, searching for online projects. As well as locations. There's some really great, unique citizen science projects that are targeted to specific locations. Like I always tell people, someday I want to participate in the California Grunion Greeter project. There's an eel project out of New York I want to participate in. So you can also search by your location. It's such a useful tool to discover existing citizen science projects that are out there and the projects that will meet your needs. So you can search lots of different ways to search and find that great project for you. One nice thing, so say you're searching for insects and pollinators, it has to have classroom materials and college students. When you do that, you'll actually create a unique link that lists, say it's 50 projects come up in the result. You can actually share that link with your students. And so that's kind of nice as well, to create customized URLs. Maybe you want to tell your students, pick one of these 50 or something of that. But the search can also have it generates a unique URL link. So just another nice feature of that. And then on the project finder page, before you begin your search, this is a really cool feature that I don't think some folks know about, so I always like to share it. You get a glimpse of the newest projects that were recently added to the database of citizen science projects. So among 3,000 projects and events, the ones that'll show up first, for example, this morning it was Project Horseshoe. That was a recently listed citizen science project. And so that's kind of nice too. You can kind of keep tabs on, wow, look what was just added. And then one quick example I thought I would just share with the group. This spring, so it's kind of a shorter like semester, not like a full fall semester, but during May and June currently, I have a section of animal behavior. The course has 23 undergraduates enrolled. They're distributed across the United States. They were going to be doing animal behavior research observations with local zoos, wildlife centers, national parks, but with the global pandemic and closures, their original plans have changed drastically, especially for about 19 of the students who don't have access to their planned sites. We do have a couple that were serving as like students that work in zoos currently, but 19 were really affected. So in the animal behavior course, my students collaborated and crowdsourced solutions. They have done an amazing job. I'm going to pop a link in. One example, just a small example, is a crowdsourced list that they created of animal behavior themed citizen science projects that can help fill the gap for some distributed students who lost access to their planned behavior site. So the students were able to create this list from the SciStarter project finder as their starting point. And so with college students, involving them in the search can be a really great activity as well. So that can be really nice. And then in addition to the project finder, there are so many resources discoverable from the SciStarter.org ecosystem, including, I'm gonna grab the link for you guys. Here it is, including a tools page, and I'll pop it in the chat pod. Here we go. There. It includes tools used for assorted citizen science projects. It's really helpful when you're planning projects for undergrad audiences and considering accessibility options and alternatives to support an equitable learning experience for all of your students. Next slide. Yeah, so in fact, that URL is at the top, but I'll grab it so you have it, the live URL, and I'm gonna pop this in the chat pod. This was a fun page. It actually was created out of some need this spring with the global pandemic, but the SciStarter.org education page, it's a brand new, very new as of this spring, curated collection of citizen science projects that check a lot of the boxes that we as educators look for, such as existing project resources for your learners, ease of use with your specific learner audience in mind, video resources, as well as really engaged, supportive, responsive project directors and project staff, which is so phenomenal to have. And the next page, we can go to the next slide, I'm gonna show an example of what one of those pages looks like. So many of you guys have probably heard of the Coco Roz project, such a great project, came out of Fort Collins, Colorado. So Coco Roz stands for Community Collaborative Rain, Hail, and Snow Project. It's one of the projects on the SciStarter education page. So you can kind of see the layout. I put the unique link in so you can see the live page, but this is a screenshot. There's a video at the top. You see at-a-glance resources, which I find so helpful, especially for labs. So materials, concise steps relating to project engagement, educator opportunities, links, and more. This is helpful as you plan to incorporate a project with your learners, that at-a-glance view. So next slide, and I'll pass it to Caroline.
Yeah, thank you so much, Jill. I wanted to show this example too of, it's kind of a sneak peek at the other things we'll be presenting in this presentation about citizen science projects you can include in your classroom. But and we're going to get more into projects that may require like more planning or a longer term like curricular commitment versus projects that could maybe be like for one lab or for one activity outside of class. One of these is stall catchers, which I think some of you know about, where you can analyze blood vessels in the brains of mice to help speed up the search for a cure to Alzheimer's disease, and it's gamified. So it's a particularly good one for undergraduate classes because you could, especially if you have a large lecture class, you could put your students into groups and have them compete against each other to accomplish the most research on different teams in a friendly competition. And this would be particularly good for maybe like a large health-related class. So we just wanted to kind of give you that teaser before we, and where you can discover stall catchers with some more info before we pass it over to Bucky. And Bucky, I think you might be on mute.
Yeah, thank you. All right, so I just want to let you guys know that I think that some of the most important stuff in this entire webinar today was just talked about. How to go to SciStarter, find stuff, and you also should recognize that there are lots of other places you can locate projects. Zooniverse is another great one that I get projects from as well. So, feel free to explore all the different avenues. So that said, I am going to be talking largely about SciStarter whenever I talk about projects. All right, so learning about backwards design principles and citizen science. So whenever you go to consider a citizen science project, you always need to go back to what is the purpose of your class? What is it that you want the students to get out of it? So I've trained other university professors. I have trained K-12 teachers a tremendous amount. And one of the biggest hang-ups that people seem to have is they don't really see how doing a citizen science project can necessarily relate to some of the broad learning objectives that they have in their class. And to me, coming up from a postdoc in which I developed a citizen science project and did other citizen science in classrooms, it was super important to me to have citizen science in my class. And so in order to make that easiest for me, I went ahead and I made one of my learning objectives, which you can see here for my intro non-majors bio class. So don't judge me, please, on these learning outcomes. But I made my 5th learning objective that we are going to basically be doing scientific work in the class. And behind that, I had citizen science in mind. So I specifically designed my class to be able to incorporate citizen science and have it meet the objectives. But most people don't do that. All right, you probably didn't do that whenever you first started out. And coming up here in the fall, when you have a new course, you have to put online or whatever else. You don't want to mess with learning objectives probably. So let's take another one of my learning objectives. Oh, next slide, please. All right, so let's go up to number 2. So this one is build connections between biological phenomena with geological, climatological, astronomical, and even economic systems. So the purpose behind this learning objective was I want students to be able to take the knowledge they're learning in my class, the biological knowledge, and be able to see connections between all other aspects of the Earth physically, but also be able to think about stuff in space, such as like meteorites hitting the Earth, right, and causing mass extinctions. Okay, but also economic systems. And this is because I have non-majors in my class. And I can incorporate things such as economics, and talk about economic theory in relation to biology. So now that's kind of opening things up a little bit more. All right. So if I wanted to specifically target this learning objective with a citizen science project, first thing I want to do is go to somewhere that has citizen science projects, so like a Zooniverse or a SciStarter, and then start searching for projects. And with this particular learning objective, I have geological, climatological, astronomical, and economic. So I did this just the other day. I went on to SciStarter. Next slide, please. And I looked for projects dealing with atmosphere, just to kind of see what was popping up. And so these 2 projects came up, and I thought, okay, this is going to be great. I'll just pick these 2 projects and figure out how I can incorporate them. And so the reason that I picked these 2 was because they seemed like interesting projects to me, things that students might have some interest in. So first off, looking at trees inside of a city, most students have not really thought about trees in a city being different than trees outside of a city. And then you have the loss of the night. And this project is all about light pollution inside of our night sky, in our cities, our countrysides. And it's looking at ways in which how much light pollution there is just up in the atmosphere. So the first project, Urban Forest Map, there's a pretty obvious connection between biology and this citizen science project. So I could send students out, they could do this project, collect data, and then in their minds, they immediately see that connection to biology. The second one, not really that close of a connection to biology offhand. Now, if you were studying, space or something, there's a pretty obvious connection there. But what else can we do? All right, next slide. So what I like to do is then step back and look at my educational philosophy. And this is something you all need to do as well. And I'm sure that you do, but it's always a good practice, I think, for every semester we go to teach. Just think about what is it that I find most important in education? What is it that I want to teach my students, and why do I want to teach my students that? Well, one of the things I try and do is give students as many ways to connect concepts. So I just like to think of it like a hat rack. How many ways can we hang a hat? And that little hat is knowledge, right? So how many ways can we hang knowledge inside the brain of the students? So I try and find multiple connections. I'll bring up DNA, but I'll talk about DNA, not just what a DNA molecule is, but I'll talk about DNA from a social perspective. I'll talk about it from a historical perspective, from a chemical perspective, and from that biological perspective. And so with all these different ways, you can touch on the different learning styles and the different interests of the students. You also need to think about the direct connection, if that is required or not required. A lot of times students like to have the answer given to them, especially the students in my class. They take my class because they don't necessarily have to take it, but they have to take a science. And so since I teach a low-level non-majors biology class, I like to go in there and say, tell me what I need to know, let me take a test and get an A. But that's not the way I like to teach, because that doesn't get to the multiple connections between a topic. And since that is one of my core philosophies, perhaps I can use this loss of night project. So I'm going to try and be a little bit circuitous by using this project. All right, so now we can talk about the ways in which these two projects here relate in a direct or more circuitous fashion. Well, with the urban forest map, we can look at how restricted biodiversity is in a city versus a natural area outside of a city, right? And what's a city? Well, a city is all about economics. It's a population center. So at that point, we can talk about population. We can talk about ways in which population is managed in terms of city infrastructure. How does that differ from large populations in the wild? We can talk about it, being regions of capitalism, at least in the United States, regions of capitalism. And I don't know, you can bring up some more economic stuff. But really what we're doing is we're looking at biodiversity inside of the city. What do people find beautiful? They're going to put those inside the gardens. So now you have that direct connection to ecology. And then what about the loss of the night? Well, I can bring that up in a circuitous way by having students do this project, look at the results, and then we can go back and talk about nocturnal animals. And do we see a connection between increased light and then changing behaviors of nocturnal animals? Because now any nocturnal animal is living inside of a human-induced environment. So those are ways in which we can bring the biology into these topics that are maybe not directly connected or more directly connected to biology. So I think this is really important, that for those of you that have never used citizen science before, to be very open-minded, be very broad, and you don't have to have that one project that relates to proteins whenever you want to talk about proteins in class. Now, there is a really, really great protein project that you can do if you'd like, but you can also bring proteins in a slightly different way. And I just find that multiple approaches philosophy to be very effective. Okay, next. And so the last thing that I wanted to say in this section was, if you go back to just really basic stuff, if incorporating citizen science is important to you, if you feel like it is something that your students are going to benefit from, just go ahead and throw it in. Because even with my first learning objective, which is just, it's silly in simplicity, just recite basic biological information, any information that they glean from these citizen science projects, it's going to be stuff that they're going to be able to think about in a different way. And so that definitely meets your learning outcomes. And so by now, basically what I want to do is just summarize really quick, in that to choose a project, one easy thing to do is just go to your learning objectives, find a particular learning objective that you want to hit on, and then just do some searches to find that project, that one project that you think would be really beneficial to students. There's a lot of other considerations that we need to go into after you choose the learning objective and after you starting to get a list of projects you might want to do. Okay, so now I'll turn it back over to Caroline.
Yeah, thank you so much. And Jill, I think you're going to tell us a little bit about ease of operations.
Yeah, thanks. And great overview. I agree that beginning with the end in mind, that backward design, the principles, it's transformative. So it'll really help you as you're planning the right citizen science project for your audience. So yeah, choosing your project. So ease of operations. I think this is really important, especially with some of the audiences that we work with. And so we're talking about materials, tools, procedures, time. Often I've a generalization I've found is less complexity is often best, especially for those first experiences in a citizen science project. We want that first early experience in citizen science, actually all science, but we want it to be positive. We want them to keep coming back for more. One other tip in terms of kind of the practicalities, the operational connections. One theme, or I guess it's a theme I've noticed. I was going to say tip, but I guess it's just a theme I've noticed with learners I've worked with. the undergrads, they really like using their mobile devices for citizen science, especially the non-science major audiences. I know some have not been enthusiastic at first about engaging in science or citizen science, but when they learn about, you know, some of the NASA Globe Observer, NASA Go projects like the Mosquito Project, they're using their cell phone. It's a free, easy app. They're super engaged. So that's just one thing that I've noticed. And then the SciStarter education page projects that we looked at earlier, the link, they were selected because they really fill the bill for meeting ease of operations criteria. So if you're poking around, that may be a great early place to look. And I'll turn it over to Caroline for some additional examples.
Yeah, these are going to be kind of rapid fire, but we wanted to give you an idea of all that's out there. So some projects are longer term, right? So something like Coast, that's based up in the Pacific Northwest, and it requires walking the beach and monitoring over a kind of longer period of time. You may, if you wanted your students to be involved in a longer term project, at the very least, like you'd have to really commit them to some training up front. Or like I wanted to give the folks at the Reef Environmental Education Foundation a shout out because they have this awesome volunteer fish survey project where people at groups can come on site, and including undergraduate groups, and be part of a program. So at the very least, like you'd have to commit to the travel for that and the for that day of the program to do the fish survey. Whereas other projects, and those are awesome too, especially if you want to make that more of like a focal point. Other projects like stall catchers and marine debris tracker. Marine debris tracker is app-based. You can see in the picture that the student is using an app to complete the project and monitor plastic pollution. And stall catchers, as we mentioned earlier, is on the web. So you do the analysis by analyzing videos. Those you could more have students do on their own, perhaps outside of class. But something all of these projects have in common is they do a really good job of reporting the results back. So I just hope that you all keep in mind as you integrate citizen science into your educational efforts, make sure people know the why of why they're doing it. You know, what are they trying to accomplish here? They're contributing data or analysis to what end? I think going with trusted projects like this is a good way to do that. Another example of data accessibility, we got Globe at Night. So if you participate in Globe at Night, you can also have your students go and look from year to year at data people have submitted to monitor light pollution. So that's another way you can integrate citizen science in. It doesn't have to be about just learning about the topic or learning about how to follow the protocols and do the project. It can also be about the analysis side of things, or you know, you'll hear about this in the later happy hour, but classes at NC State, there have been English classes that have assigned citizen science projects as a way to teach science writing. So there are so many different skills you can address with citizen science, and I hope that you consider Globe at Night and some of the awesome data accessibility it has if you're interested in teaching that skill in your courses. I also wanted to give a quick sneak peek, I can't talk today, a sneak peek of Earth School. So that's a program of TED Ed and the United Nations Environmental Program and a number of other partners. And the awesome team at the Wilson Center, so Ann Bowser and Matisse Malash, they are creating some really cool data visualizations of different citizen science projects as part of Earth School. Earth School is K through 12, but I think there's some value for undergrad learners as well for different portions of it. So this is iNaturalist right here, and it's bee data. So different types of bees that have been categorized by genus from April 22nd, so Earth Day 2020, until May 8th. So it's not released yet. You know, you all are getting a quick look, but when the Citizen Science Quest for Earth School drops on May 27th, learners will be able to explore these types of data visualizations for citizen science. I just thought this was really cool, and I love seeing this type of thing for citizen science. It's just another way for students to think about how the data has been submitted. And Earth School is actually live right now for a bunch of other quests that don't involve citizen science, so I just wanted to show this image to you all of cool citizen science data viz coming soon. So need a project next week. Jill, how do we find one?
Yeah, great. So yeah, some of you guys may be prepping for summer one or fall, or you're doing a Maymester now. Many may be online or distributed where it wasn't going to be. So again, the education page and the project finder, great places to start. You know your audience, know your needs. Think about your learning environment, the modality that you're going to use, and again, using the backward design principles. Know your student learning objectives, your learning outcomes, and really you'll be able to plan your citizen science engagement experiences from there. It really creates kind of it just facilitates that planning and implementation. And again, thank you all. Our other colleagues have shared additional resources, fantastic. And the researchers that are out there, we really invite you, list your projects and classroom materials with SciStarter. You just fill out a form and it'll be online. It's free, easy, and people around the world are looking.
Definitely. So even if your project is hosted on like Zooniverse or like any platform really, if you have classroom materials, make sure you note that when you add it to SciStarter for folks to discover it. Because I mean, this is prime time. That's why we're having these happy hours. Folks are looking for citizen science to incorporate into their curriculum.
Absolutely. I know out of kind of a challenge of the spring, it's created some really great dialogue. So now we're in for a treat. We're going to be serving dessert with our Citizen Science Happy Hour. So I'm going to pass it to Bucky to dish and serve this treat for the group.
And Bucky, I think you might be muted.
Yeah. I got it. This thing is so difficult to work with. Okay, it should just read my mind. All right, so I was just answering a question on the Google Doc about this, and I urge all of you, if you have questions, to go on there and write stuff down. All right, so the question was about how many projects should you do at one time? And I am an absolute glutton for punishment, and so I jumped in more than head first. All right. But I recommend you guys just start out slow, do one project just to see how it goes, get your students kind of into it. And ultimately what I have ended up with through all of this is a really complex kind of what I'm calling a 5-layer cake of citizen science. All right. So the way that you want to do this, if you want to do more than one project and have them linked together, there's a really simple formula for doing that. Right? And it's really like thinking like a scientist, okay? So first, find your overarching question. What is it that you want to know? And so for me, my overarching question was, what's the ecology of NC State? All right, so now I think that a lot of citizen science projects should have very large overarching questions, especially ones that go for a long period of time. I have another project, my shark tooth forensics project, and its question is, what's the ecology of ancient sharks? I mean, that's a stupidly big, broad question, but it allows for so many ways to use it all through education. All right, so once you have your overarching question or the goal that you want your students to do, the next thing you need to think about is what projects can you put in there to support those goals? And I'm going to show you those projects in just a minute. And then the last thing is to link those projects together based on the individual collection protocols for the citizen science projects. And now I think what I'm going to do is just dive straight in to this big old chocolate cake. All right. And then tell you what I mean by that last term. All right, and I apologize for this because it's a dang good-looking cake. And ever since I found this image, I have been craving chocolate cake more than you guys know. All right, so you can see my overarching goal, the big project at the top. So what is the ecology of NC State? Now, if we think of this big question as the icing, I think it's going to go really, really well with this metaphor. Okay, next, the very first project, let's go to the bottom layer. That's going to support everything here. That's Caterpillar's Count. So Caterpillar's Count is a project out of the University of North Carolina at Chapel Hill by a bird researcher who is interested in what birds are eating. Now, what underlies what birds are eating is what arthropod diversity is present in your ecosystem at different times of the year. So his project is all based on individual localities, and he has very, very specific ways in which you must collect the data. It's just standard data collection protocol, so anybody doing it will allow for the data to be collected in the same way, and there's going to be minimal bias. So because that project had the most strict protocols for collecting data, I wrapped everything else on my question, all of the projects, around those data collection protocols. So basically, I had to find one tree as the center of what's called a tree circle, and then a number of trees surrounding it. And then I followed that same protocol multiple times on NC State's campus. None of the other projects require trees be positioned in such a way. So I now have all these mini laboratories all over NC State, all following the same geographic locations designated by Caterpillar's count. All right, so now that I have this diversity of trees, what I wanted to do was to start looking at the biodiversity from the smallest to the largest. All right, so Backpack. So Backpack is a project that I started because I needed to study the bacterial biodiversity on the trees. It's not a citizen science project yet. I am hoping to get it all up on a website so I can share my data out, because I'm not a bacterial researcher. And so I'm hoping to get a lot more collaboration going on with this project, but it is a project that I wrapped around all of these trees. So students will collect bacterial data. All right, and then there's backyard beetles. So backyard beetles, these are really small arthropods. They're little beetles that live inside the bark of the trees. Okay, so now this project is based out of the University of Florida in Gainesville, and they have a really great website, data collection protocols, everything. You simply collect your beetles, you ship them off to the University of Florida, they identify them for you and send you back the data. Then we also do triangle bird count. So the triangle bird count is a brand new project that based out of NC State. And this project is basically just looking at all the bird diversity around the triangle. So within this, what we do is we look for the birds all around the trees that my students are looking on. So now we have a nice little ecology forming here. We have the insects, so the arthropods from the Caterpillar's Count project. We have bacteria that occur on the leaves and also occurs on the bark of trees. We have backyard beetles, which looks at bark beetles, so the beetles that live on the inside of the tree. And we have the triangle bird count. So we're looking at the birds that live inside the trees and that are also potential predators of the bark beetles, as well as the arthropods that are on the trees themselves from the Caterpillar's Count. And the bacteria, well, maybe that gets there by insects, maybe it gets there by airborne sources, maybe it gets there by the birds, who knows? Honestly, not very many people know, to my surprise. So we have this nice ecology starting to form there, and we can talk about it. So at the very tippy top is Nature's Notebook. And this is kind of the biggest scale of our the projects here, because it's looking at how tree phenology is changing. At least that's the way I'm using Nature's Notebook. And so we can start to see when the trees bud and when the leaves fall off of the tree. Some issues that I had with this is that, especially the leaves falling off the trees, it turns out that most of the leaves don't fall off the trees before my semester ends in the fall. So I haven't really been able to incorporate this really well in my class. But nonetheless, I was very carefully looking at my question of ecology and then slotting different projects in that would help me fill in blanks within the ecology of a single tree. I assign students, I have huge classes. I have 200 students in my classes. So I assign them into groups of 5, only 4 or 5, and then each of these groups gets a single tree. And the framing of this project is that at the end of the semester, they're going to be the world's expert on that tree. No one in the entire world is going to know more about that tree than them. And it's absolutely true, because they're going to collect the data, but they're also getting to see the data from all the previous years. So they are going to be the world's expert on it. And so they continually going back to the same tree, the same tree, the same tree. They collect the data And sometimes they get the data from the websites of these projects. Other times I have them submit the data to me, and then through a Google form, and then they can pull it up later. But ultimately we end up with a poster presentation where they look at everyone else's posters in the class, and they get information about what they did really well, what they did badly in terms of making posters, so data visualization. But they also get to see what other people found. So if you want to be crazy, you can add stuff like this. You just layer projects, and layer projects, having them all linked together through a single question. You also can simply just add in a bunch of random projects to supplement individual topics that you're doing. So I could talk about this for a lot more, but we only have 15 minutes left. And I really wanted to go to the question doc and open things up so to get a little bit more conversation going.
All right, what questions do folks have? What did they put in the doc? I'll go ahead and stop sharing my screen so I can take a look too. Looks like one question that I see is, for those of us at smaller schools who teach courses every other year, is that okay? Or do projects require/expect data to be added annually? Depends on the project. Many are open, and Jill already answered it in the chat. Go Jill! Many are open to participate in as little or as more as you prefer. And let me find the Google Doc so I can just drop it in one more time for folks so we can all be in there together. And if you think of things after this presentation as well that you want answered, we have a little group going on of people who have been presenting on these different higher ed happy hours. I know we're going to try to get to each and every question there in all these different Google Docs.
Yeah, so if any of you have a question right now, you can just go ahead and unmute yourself and ask away. Oh, and by the way, those of you who have used citizen science often in class, please contribute to that doc. Help answer the questions.
These are some really good questions.
Okay, there is one that I wanted to bring up from Sally in the UK. And it's one that I've had to deal with a lot, and that is, how do you get other academics who are not convinced that citizen science is worth presenting to your class to back you in doing it? So this is one that I have had to deal with in my university, and a large part of that has to do with your students. So you and your students have a relationship, which you guys know, and it's a relationship about trust, and it's a relationship about information. They walk into that classroom, and if you can develop that sense of trust, and if you can convince them that what they are about to do is beneficial, and then show them that it was beneficial, and help them understand that doing a citizen science project led them to know that material better, then you're going to get buy-in from the students. And if you can present information in terms of more positive reviews on your final reviews from the semester, or if you can show by some education research that you have better outcomes in classes that have citizen science versus those that do not have citizen science, then that's really good data that you can get backing from other researchers and other teachers in your university.
Yeah, this is Jill. I completely agree. That's such a great tip. And in your department or your team, however you're organized, find the omnivores. We've got a lot of life science folks. Find the omnivores amongst your group, the folks that are willing to try stuff, the fellow faculty, because I've seen that spread. Somebody starts something, get great results, start sharing, maybe collaborate with a colleague who's kind of open to new things, new ideas, and then it just spreads. So yeah, great one.
Yeah, and start simple.
Yeah.
Really, really simple. And just show, hey, we did this cool thing. It was not hard. It was really easy. And just keep going like that.
One question came through. Someone asked, are there any citizen science projects that you are aware of that take non-science major students through the scientific method in an introductory fashion, including describing what the scientific method is, how to collect data, what type of data display is best to use with the data, what is a scientific poster, etc.? It's a tough one.
Yeah, offhand, I don't know of any, but I mean, I use that all the time with my student. I just pull in a project and I'll say, look, we are doing this particular project. Say, I'm just going to throw Caterpillar's count out there again. And this is the scientific method behind it. This is the question. All right, this is the way that we have to do things. Why do we have to do it? Well, you have to do it this way because everyone has to collect data the same way. And they have great visualization tools on their website. So I can just pull things up, show the visualizations. So I just do it with individual projects, trying to explain why the researchers developed their project in that way.
Yeah.
You guys know of anything?
Oh, sorry. Yeah, I was agreeing. That's a great, I've seen that as well, where some of it's not built in the project as that kind of education component, but you're right, like we can do it, right? When we take that and then translate some of it for our students. I know I've seen it done beautifully also with eMammal, where it leads with a question. We're not just looking at pictures of critters. You know, there's cam traps in suburban areas and rural, and data are being collected and analyzed for differences. So you've got an independent variable there. So you can kind of teach that in that context. And then what we do, you know, science isn't done till it's communicated. And so in a lot of our courses where citizen science plays a role, students do a poster session afterwards. And so you can kind of take citizen science projects and then knowing what your students need, add or build things in. And even in an online classroom, we have a PowerPoint template, has kind of small font, which some of them get upset about, but we do have like poster sessions in the virtual classroom where they're communicating out what they discovered. But yeah, great question. That's a great website too, Marnie. I love that website. Understanding Science, yeah.
Ooh, here's a good question. Do you interact with the project managers, guest lectures, ongoing collaboration? It definitely depends. I think NC State, they're just so blessed because you all have so many amazing citizen science project leaders on campus who could probably pop around to each other's classes.
Mm-hmm.
But a lot of project managers are very receptive to receiving emails and happy to, especially in our new digital world that we're living in, happy to pop in probably to a Zoom call. And at SciStarter, if you ping us at the info@SciStarter inbox, we're always happy to kind of talk things over with you. We have weekly office hours and try to help you find a guest speaker for your course. Oh, this is a good question for Bucky and Jill, because Bucky can kind of address the in-person aspect and Jill the online. Do you send students out on their own to collect data? Is there a facilitator or instructor with them? And do they sign liability and safety forms?
I've never even thought about liability and safety forms. So no to that. So in my class, I just send them out on their own. Yeah, I give them a big talk about messing up other people's data, and that them messing around, you know, if they wanted to go in and just kind of screw around, just plug in data and leave, that's not hurting me. It's not hurting them. It's hurting someone else, and it's hurting someone else's project, because that's what ultimately happens. And it's not just hurting a single person who developed the project. Ultimately, it's hurting the entire world, because that data is going to be used in a scientific publication. And that knowledge belongs to all of us. So I just try to develop a sense of integrity in them and a sense of importance, and that the students themselves are doing something important. They're contributing to the world, that it's not just a throwaway, go out there and measure this thing for no reason. So yeah, I just send them out and cross my fingers and hope for the best.
It looks like Andrea from Clark University says, my students have to sign a liability form, including acknowledging they could die from the activity for every lab we do.
Oh my God. Well, that's covering yourself.
Yeah, we have that in some of our courses, and I'm the same. The world is their lab, they're distributed, so they're out on their own. Locally engaged, globally connected citizen science. So, you know, you're exactly right. That shared data, it's critical that is authentic data. You know, it's critical for the science that the data that they're submitting is is representative of what they observed at that time and place. And I know for example, some folks earlier were talking about the City Nature Challenge. That's a great one because it's locally engaged, globally connected citizen science using the iNaturalist platform. We use that in a science class, and then also it's part of our April is our Global Days of Service month also, and so it was a project for anyone to get involved wherever they live. But that was a great one because I was the one teaching the spring citizen science class where City Nature Challenge was a part of. But what I'm getting at is I was able in their iNaturalist accounts to kind of see what they're observing, give feedback, get their observations to research grades sometimes. So yeah, lots of ways to do that. But so far so good. I mean, they really do embrace using the world as their lab. And then what they really love too is sharing. Sometimes we have students surveying different bodies of water, and then they get into really great dialogues about water quality and what they found, their observations. That's been pretty fun to watch because I've done other labs where we all go out to a creek and we sample the same area, and that's great too. We discuss it, but it's been really neat to see how geographic differences enrich their discussion of what they found. So lots of ways to go. It's just, I just encourage everyone to jump in and keep sharing your ideas because it's such a great area and it's getting better with more people trying different things out and then sharing what they found. It's really exciting.
We have a question here. Someone's wondering if we have any ideas about how to recruit community partners for citizen science projects.
Ooh, yeah, that's great. So we do that a lot because we have students, all over the U.S. Zoos, museums, nature centers, .orgs, the informal science partners, local, state, national government organizations, all of the above. I think just don't be shy and really reach out. And honestly, whenever we reach out, people are really excited and they want to collaborate and help. So I maybe just kind of get a sense of the geographic area you want to target, and then just kind of go for it. Whoever you want to work with, just reach out and see what can happen.
Yeah, that's really good feedback, Jill. Looks like there's a question at the bottom of the doc that I see Bucky typing an answer for. It's, does anyone have any studies that show how this is an evidence-based practice? Can you point me to those studies? Additionally, what complications or contradictions might be present? Obviously, we're talking about the pros, but are there any known cons?
Yeah, there's some studies. I think there was a citizen science issue of, I think it was in the journal. I might be wrong. There's also great articles in the Citizen Science Association journal, but there was one, and a couple of them have had this theme where students, they don't always see gains in content knowledge after citizen science. However, we see a lot of other gains like the pre and post. So some of the folks might think, oh, well, if they're not gonna, score better on the bio test, why do it? But there's so many other gains: awareness, science literacy, interest, self-efficacy, and learning and doing science. We could go on, right? So yeah, I don't have specific literature to pop in the chat pod, but there's a growing body of literature. And I think as more of us try things out and engage our students in citizen science, it'll be important to measure the outcomes and share and learn from each other.
Yeah, absolutely. I just want to echo that the real gains I see is not the content. Provide my students with the resources for the content. The projects for me are ways to cement that content for them. And then what I hope they gain from it, independent of me, is that self-efficacy, that awareness, that ability to contribute to the world while still doing education.
One con I was thinking about just in general for citizen science in classrooms is for some students, especially like entry-level undergraduates, this may be the first time they've been exposed to science, in a meaningful way, beyond just like high school science. And you want them to have a good experience with the project. So if you're going to use a citizen science project in your class, I'd recommend doing it yourself first rather than just assigning it to the students to make sure it'll be a good experience for them. And also to make sure it's active, because there are lots of great projects out there, but sometimes project owners can get caught up in other things, or like maybe the project falls by the wayside, and you don't really want your students' efforts to be for naught. So just make sure you do the project first to vet it, so they have a good experience too, and they aren't turned off science forever. We want this to hook them on science, not alienate them.
Yeah. And another quick con that I'm thinking about now is grading. And I just brought this up with, or it was brought up to me by a lab manager, is that how do you grade a citizen science project when you're taking real science data and you don't know what the answer is going to be ahead of time? And each individual submission could be different data, because that is reality.
I love that. I love them getting comfortable with the unknown. Yes. Yep.
Wow, we're right at 4 o'clock. Any other questions from folks last minute before we go?
May, did you want to show them really quick our contact info in case they wanted to?
Ooh, good idea.
You guys can take a screenshot of it.
Yes, let me share my screen. Yeah, get in touch. We'd love to hear from you. Tag us on Twitter, shoot us an email.
Yeah, and this is just one small group of my students in the background taking Caterpillar's count data. So you see, I have tons of students out there working, and they end up talking to each other, which is great.
Was this on campus?
Yeah, this is NC State's campus.
Awesome.
Yeah, thank you all today, and thanks for everyone for being on the line today. We had another big group, and it's so exciting to see so many people interested and new to incorporating citizen science in their class. I think it's great that we have so many folks on these calls. We do have 2 more coming up. Caroline, do you have that slide on that?
No, I don't. I'll stop sharing.
It's fine. They're on June 5th. There is one on assessment. And so for those of you that are, I think there's been a few questions come up today that are more assessment focused. And so if you were interested in that, on June 5th, there'll be another group of folks coming to talk about that. And then on June 12th, we'll have another panel talking about citizen science and non-STEM courses that I think will be really fun and interesting. I'm going to go ahead and stop recording.